We're going to be doing a factorial data analysis. Our factors are gender and stress, and our dependent variable is weight. Gender is a nominal variable. We have two categories. Our categories are male and female, with a value of 1 indicating male, a value of 2 indicating female. For stress, that also is categorical, but it's categories that you can rank, so that makes it ordinal. Our two categories are value of 2 for mid-level of stress and a value of 3 for high level of stress. There is no value of 1 because none of the people reported having a low level of stress. In terms of a factorial design, we have two variables, gender and stress, and each variable has two levels, male and female, mid and high level. That makes this a 2 by 2 factorial design. We're going to be interested in three different things. First, is there a main effect of gender? That is there a difference in average weight of males versus females? We'll also be interested in whether there is a main effect of stress. That is there a difference in weight on average between mid-stressed people and high-stressed people? Finally, we'll explore whether there's an interaction between gender and stress. By this I mean, are males who are highly stressed, do they experience a greater weight gain compared to females who are highly stressed? Let's go ahead and do the data analysis. For our data analysis, we'll click on the Analyze drop-down menu. We're going to be working with the general linear model, univariate, that is if there's one dependent variable. Our dependent variable is body weight. We're going to have two factors, gender and stress level. For options, we're going to go ahead and click on Descriptive Statistics so we get the average weight for males mid-level stress, males high-level stress, females mid-level stress, and females high-level stress. So we'll get those four means. Also, it's always nice to have a graph of your results, and so we can go ahead and identify for our graph which of these two factors will be on the horizontal axis. I'll go ahead and put stress on the horizontal axis, and which one of our factors will be represented by separate lines, and I'll go ahead and choose gender for that. So that one line will represent males, the other line will represent females, and I'll say add and continue. Okay, we'll go ahead and do the data analysis, clicking on OK. SPSS is going to give us the output. The output will allow us to evaluate whether the difference in weight between males and females is statistically significant, whether the difference between mid and high level stress people is statistically significant, and whether the interaction between gender and stress level is statistically significant. So up here we're told that we have 5 males and 15 females. 12 of our participants had a mid-level stress and 8 of the participants had high level of stress. For our descriptive statistics, we see for males the mid-level stress, their average weight. For males with the high level stress, here's their average weight. For females, mid-level stress, here's their weight. And for females with the high level stress, here is their weight. We also have the results of the inferential statistical analysis. For the factor of gender, we see that the F value is 20.284, a very large F value. And if the null hypothesis is true of no difference in weight between gender males and females, the probability of us getting this result due to sampling error is essentially 0. For the difference between mid-level and high-level stress people in terms of their weight, it appears to be statistically significant. The results of this happening due to sampling error, if the null hypothesis is true, is 1 in 1,000. And finally, there also was an interaction between gender and stress. Again, probability of this result, if the null hypothesis were true, happening due to chance being 0.026. We also have our graph where we can see that there appears to be an interaction. Just looking at the graph itself, these two lines, rather than being parallel, look like they'll be intersecting at some point further down the graph. So when your lines are non-parallel, that's an indicator, not a guarantee, but an indicator, that results that there is an interaction, which can be confirmed by looking at the results from